Welcome back for the second part of solving inequalities lesson. In this video, I'm going to go over solving rational inequalities with you, okay? Let's write part 2, solving rational inequality. So it's going to be really similar to that first part where we solved the polynomial inequalities, but for these ones, the boundary points are a little different, so we have to be careful. So do write down, let me see. I'm going to go over about 3 examples with you, just three, but then I will ask you to try one on your own, just one problem, okay? So this will be maybe a little bit shorter. So here we go, example 1. I'll ask you to solve x plus 5 over x plus 4 is less than or equal to 0. So do write this for me first. Now, here's how we do this. Whenever we were solving a rational equation, right, we would multiply both sides by the denominator. Now, but here's the thing. If you multiply both sides by x minus 4, I mean, that x minus 4 will cancel out, but that x minus 4 could be a negative number. You see what I mean? Like, what if x is 3? What if x is 3? Then 3 minus 4 will be a negative 1, and multiplying both sides by a negative number we're going to have to flip this inequality, right? So that's something that we're not allowed to do here. Instead, here's how we do the boundary points. First, check and see if the other side is equal to 0. That's where we want to start. If it's not equal to 0, we have to work with the fractions a little bit. But since it is 0 on the right side, we're ready to start. Write this down for me. Find the zeros of the, here's how we start this. Find the zeros of the numerator and the zeros of the denominator. Okay? And these numbers are going to be our boundary points. Okay? So let's first find the 0 of the numerator. Now look at the numerator. The numerator is x plus 5, right? Set that equal to 0. What's the first 0? X equals negative 5. So circle that. The denominator is what? X minus 4, right? Set that equal to 0, and you're going to get x equals 4. So whatever that makes the top of the fraction 0 and whatever that makes the bottom of the fraction equal to 0. One of them is 4 is something that we're not allowed to have. So when we graph these two numbers on a number line, just like how we were doing on our polynomial examples, well, do graph a line for me and put the smaller number on the left. Negative 5 is smaller, so put negative 5 on the left and put 4 on the right. Now draw the circles, but for rational inequalities, you have to be careful, okay? You will never close the circle for the 0 of the denominator because we're not allowed to have 4 in this position because 4 minus 4 will result in 0 in the denominator. So we're never going to leave. So we'll say 0 of the denominator. Make a quick note. Always use an open circle. Okay, so for 0 of zeros of the denominator, you should always keep it open. I'm going to keep it open. But do you see why I'm going to close this one? Look, it can be less than or equal to 0, less than or equal to. And when x is negative 5, that's what's going to happen. So take a look. If x is negative 5, then I will get negative 5 plus 5 over negative 5 minus 4. That's going to give me 0. So it's okay for this circle to be a close one. But you understand why we are never closing this 4. Because I'll show you. Okay, why not? Take a look. What if I change that x value to 4? 4 plus 5 over 4 minus 4. What will happen? You can't divide by 0. So that's why we're never closing this circle, okay? And that's one thing that you have to be careful when you're solving rational inequalities. Because for the polynomial inequalities, they're all either open or closed. They were all the same. But this one, you may have one that is open, you may have one that's closed, so you just have to be careful. All right, now we're going to do the same plugging in. We're going to just test these values. I think Alex does this in a little better way. Like they, you know what? I'm just gonna do how I do it. All right, I will plug in a value that is smaller than negative 5. I picked negative 6. I'm going to plug in negative 6 to test that interval. So that will be negative 6 plus 5 over negative 6 minus 4. And if I simplify that, I will get negative 1 over negative 10. And negative over negative, right? Negative over negative is positive. So I know to the left side of negative 5, I'm going to get positive numbers. Okay? All right, let's plug in a value in between negative 5 and 4. Well, what's a good number to plug in? 0, because 0 is always in between a negative number and a positive number. So plug in 0. 0 plus 5 over 0 minus 4. This fraction turns into 5 over negative 4, and that's a negative number. So this one will be negative in the middle. And let's do the last interval. Let's plug in x equals anything that is bigger than 4. I will go with 5. Okay? Then that will be 5 plus 5 over 5 minus 4. That turns into 10 over 1, which is a positive. So I'm going to have positive signs right here. Now, what did they want? Take a look. We want to find the interval that are less than or equal to 0. Less than or equal to 0 means we want the negatives. So we're looking at it. Our solution, our interval is right there. But when you write your interval notation, we have to be careful. You notice that one is closed circle. This one is open circle. So here we write the answer, the solution is from negative 5 to positive 4. But notice I drew a square bracket in front of negative 5 because we have a closed circle right there. And after 4, just draw your parenthesis. So that's it. That's example 1, and that one I consider to be like the slightly easier version of the ones that I'm going to show you because it was already 0 on the right side. And if it's not 0 on the other side, we have to do some work, which is not that bad. We can do this. All right, so let's try example 2. Let's do example 2. Let's keep going. Hopefully you're doing okay. Let me get another piece of paper. All right, this one, I'll write it and I'll move my hand so that you guys can write this down too. And I'll focus a little better too. Okay, now this one, I have 15 over x minus 3 is greater than or equal to 5. All right, now we got a problem, right? Because my camera is so blurry and we don't have a 0 on the right side. So what do we have to do? You have to subtract 5 from both sides first. So this one, I can't find the zeros of the numerator and the zeros of the denominator yet. I have to move this 5, subtract 5. So it's going to look like this first. 15 over x minus 3 minus 5 is less than or equal to 0. And you're like, why does it look so awkward? Because I'm about to do something. Take a look. I can't subtract 5 from 15. I need to first make this 5 into a fraction, right? And in order for you to subtract fractions, you better have a common denominator. So I'm making this 5 into a new fraction. that has x minus 3 in the bottom. Where did I get this random x minus 3 from? I'm trying to match that denominator. But you can't just put x minus 3 in the bottom of the fraction. You need to also put that on the numerator. So, not gonna go there, but what if I just cancel these out? And they can, right? That will just go right back to 5. But that's good. I needed to do that so that I can actually subtract and write this as a single fraction, okay? Let's try. So the numerator will be, and I'll write this. You know what? I'm going to go ahead and highlight this. 15 minus 5 minus 3. That's going to be our numerator. And because so many people kind of make that silly sign mistake, I'm going to go ahead and I will first put these numerators together first. And notice we don't subtract the denominators. Don't do that. What I wrote down is just what I circled in yellow. 15 minus 5 times x minus 3. You will have to distribute the negative 5. Okay? You will have to distribute the negative 5. So what will that be? 15 minus 5x. And then what's the sign? If you do negative 5 times negative 3, that will turn into plus 15. X minus 3 is greater than or equal to 0. And let's simplify this. Notice the like terms. I have positive 15 and another positive 15. So that will turn into negative 5x plus 30 over x minus 3 is greater than or equal to 0. Now, this is where I got you started on example number 1. Notice that we had to do some work, nothing too crazy. We had to just first put them in a single fraction before we can find the zeros of the denominator and zeros of the numerator. So let's actually solve this rational inequality. All right. So do find the zeros of the numerator and denominator. Okay? So 0 of the numerator will be negative 5x plus 30 when that equals 0. So I'm going to solve that. And the other one, x minus 3 equals 0. So I'll also solve that. If I solve the numerator part, I'll get negative 5x equals negative 30. X is 6. So I got the first boundary point to be positive 6. Let's do this one. Add 3 to both sides. The second boundary point is at positive 3. Now, let's go ahead and graph them in a number line. Small number, 3 is a small number, 6 is a bigger number. So I'll have them in a way like this. Now, remember, one of them must be open. One of them must be open. Which one must be open? The 0 of the denominator. Look, this is the 0 of the denominator, right? So that means you need to use an open circle. And now if you're confused, if you're like, ooh, which one has to be open? Plug them both in. See, I'm going to plug in 6 into x, okay? Let me show you what happened if I do that. Negative 5 times 6 plus 30 divided by 6 minus, what was the number in the bottom? What the, oh, I was going to plug in 3. I was looking at the wrong number. All right, let me change that to 3, okay? Sorry. I was like, what am I doing? Okay. I'm changing that to 3. And if I plug in 3, what happened? It says 0, divide by 0 error. So this one has to be open. This one has to be open. Okay, that one has to be open. Now think about this one. Can it be 6? Can it be 6? Let's think. They did say it can be equal to 0, right? And this fraction will turn into 0 if the top of the fraction is 0. But if you want to test it too by just plugging in, excuse me, negative 5 times 6 plus 30 divided by 6 minus 3. If I type this in, I will get 0. And when this inequality said it can be equal to 0, this 6 will get closed. Now again, never use closed circle for the 0 of the denominator, okay? All right, now let's do the fun part, plugging in. All right, let's plug in a number that is smaller than 3. Plug in x equals 0. 0 is smaller than 3, so I'll plug in that. If I plug in 0 into this inequality, I will get negative 5 times 0 plus 30 over 0 minus 3. Let's see what that is going to be. The numerator will be positive 30. The denominator will be negative 3. Therefore, the sign will be negative, 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 negative. That's going to be negative. Let's find something in the middle. Let's plug in x equals 4 or 5, up to you. But if I plug in x equals 4, I will get negative 5 times 4 plus 30 over 4 minus 3. The numerator will be negative 20 plus 30, so 10. The denominator is 1. Therefore, I will get a positive number. Positive, positive, positive. The last one, let's plug in a number that's greater than 6. Plug in x equals 7. Okay, I'll plug in x equals 7. Negative 5 times 7 plus 30 divided by 7 minus 3. The denominator is 4. The numerator is going to be negative 5. So that is a negative number. Negative, negative, negative. So let me go ahead and find, I got everything filled out. I'm just going to find where is it greater than or equal to 0. Greater than or equal to 0. We're looking at the positive sign right there. So here's a solution. I'm out of room, so I'm just going to write the solution up here, okay? So the solution to this inequality is from positive 3 to positive 6. But notice, after 6, I have to draw a square bracket because we had a closed circle. But in front of 3, do draw a regular parenthesis, okay? Now that's it. That was the second one. And it took me the entire page here because I had to first work with the rational expressions. But let's do one more that is similar to this, and then I will ask you to try one problem on your own. Okay? All right, example 3. I like this document camera a lot, but I just wish it stay focused longer. Maybe I'm doing something wrong. But I'll show you this one. Last one. Example 3. And this inequality has x plus 1 over x plus 3 on the left side. And I will say that is smaller than 2. If you want to use math way to check your answer, I guess that's okay if you just want to check it. But when you submit your classwork, I'm not just asking you to show me the answer. I need you to show me all the steps that you took in order for you to find that answer. So let's start. I do want you to move the 2 to the other side first. Oh, hold on. Sorry. So that will be x plus 1 over x plus 3 minus, right? Minus 2. Is less than or equal to 0. But you see why I left all this awkward room over there? Because I'm about to make this 2 into a fraction that we can subtract from this first fraction. I'm going to have x plus 3. I copy that denominator here, but I'm not only putting that in the bottom of the fraction. I should have that on top too, so that it's really, we're just multiplying this 2 by what? 1. So we're not really changing the inequality or this value. We're just making it so that we can actually subtract them. Alrighty, so put the numerators together for me. Remembering to distribute the negative 2, not a positive 2. So that will turn into, oh look, x plus 1 minus 2 times x plus 3. All divided by that common denominator of x plus 3, and those guys are less than or equal to 0. I love to put like less than or equal to or greater than or equal to on your rational inequalities problem because I want to see if you can tell which circle will be closed and which circle will be open, because it'll be boring if both of them are staying open, you know. But definitely, if I put it like this, you are going to have one circle that is closed and one circle that's going to be open. All right, let's keep going, sorry. Distribute the -2. I will get x plus 1 minus 2x and minus 6 all over x plus 3 is less than or equal to 0. Almost done. Let's go ahead and combine the like terms. X minus 2x will give us negative 1x. And then 1 minus 6 will give us minus 5. And the denominator is still x plus 3. It's less than or equal to 0. And you know what? I'm going to go ahead and solve this now. And you know that's not the final answer. But we did some hard work to get there. Okay. What do we do next? We're gonna have to find the zeros of the. Let me move this up like this so that I can use the bottom of this page. What am I clicking? Oh no. Give me 1 second, guys. I just checked this device out from the the IT center. I don't know if this has a light. But anyways, do right. Find the zeros of the numerator and the denominator. And these are your boundary points, right? So set the top of the fraction equal to 0. Set the bottom of the fraction equal to 0. Okay? But note that well, let's keep going. So if I add 5 to both sides on this one, I'll get negative x is equal to positive 5. That means positive x equals negative 5. That's my first zero or boundary point. Let's do that one. Subtract 3, x equals negative 3. And these are the 2 points that I will graph on my number line. Smaller number, negative 5 on the left. The slightly bigger number, negative 3 on the right. And let's decide which one is open and which one is closed. Now remember, this is the 0 of the denominator, right? This is the 0 of denominator, which means always use open circle. Always use open circle because the bottom of the fraction really cannot be equal to 0. And I just had to find it because that's going to be my boundary points. But leave it open. But this one, this is the value that will make the numerator equal to 0. And because it says less than or equal to 0, this is the one that will get closed. Alrighty. The easiest part, right? We're about to plug in some values. I'm gonna pick x equals negative 6. Okay. I'll plug in x equals negative 6. Oh, I can't see my. Hold on. Maybe I can zoom out. Thank you for your patience as I'm getting used to my new teaching method, right? All right. So plug in negative 6 in our inequality. That will be negative 6 minus 5 over negative 6 plus 3. That is 6 minus 5 over negative 3. So I will get 1 over negative 3. That's the negative number. Oopsies. Okay. Now let's plug in a number in between negative 5 and negative 3. You know, very often people accidentally plug in the wrong number. They will plug in something like negative 2 or negative 6. But what's really in between negative 5 and negative 3? Negative 4. X equals negative 4. Then I'll get negative 4 minus 5 over negative 4 plus 3. And this is going to be 4 minus 5 over negative 1. So this turns into negative 1 over negative 1. Oh, hello, this one is a positive number. Positive, positive, positive. I just want to say this will be a negative, but I better check it. I shouldn't just guess it. So this one, let's plug in a number that's greater than -3, and I'm just gonna use 0 because 0 is bigger than -3. So that will be -0 minus 5 over 0 plus 3, and that's just -5 over 3, and that is a negative number. So this will be my answer, negative, negative, negative. And I'm gonna get my yellow highlighter, and I'm about to highlight all the regions or all the intervals that are less than or equal to 0. So here is one region that is less than or equal to 0, and here's another region that is less than or equal to 0, both with the negatives, right? So let's write down the solution very carefully. Just looking at the yellow highlighted part that I just highlighted. Look, here's our solution then. Solution, and this one, you have to be careful. This interval goes all the way to the negative infinity, goes to -5 and stop, but draw a bracket, a square bracket, as -5 has a closed circle. Jump this plus region, we don't want that. Open a parenthesis for this open circle, put -3, comma, and this one goes all the way to positive infinity, right? So that's it. That is the solution for our last example. Now, I'm going to ask you to try one, okay? On a separate sheet of paper, I just want you to try one. You did try 2 problems for polynomial inequality. And I think I'm just going to ask you to try one more, one for the rational inequality. So for classwork, for rational inequality classwork, try to solve this one for me. Solve x minus 6 over x plus 2 is greater than or equal to 5. Now, this one was given on last semester's exam too, and I do want you to be able to solve something like this. So do this for me. Scan it and put it on Canvas. Submit it on Canvas. I look forward to checking your work. Please don't wait until Sunday, guys, okay? Now, that's going to be it for this week's lesson. In addition to submitting those classworks on Canvas, just like how you were submitting your class or daily problems in class, I do need you to keep on working on your Alex homework. I think it was like Alex homework 2.6. Has about what? It has about 7 objectives, just 7. 4 being the new ones, and I got a couple more reviews on graphing rational functions. But if you got behind, Alex won't just let you skip those topics. You have to make sure that you work through them. So if you got behind, you didn't do much homework in the last couple weeks, then you will see all these new topics or the past few topics showing up. And you have to do them because you didn't get to do them before. So just email me if anything is locked, like if you want to finish your schedule knowledge check too, because some of you got zeros there. So just email me. I look forward to hearing from you, okay? And well, that's it for this week. Well, thank you for watching. Have fun working now.